Hi, my name is Elias Stangelaskin, and I'll be presenting a paper at ACL 2023 titled Why Did the Chicken Cross the Road? Rephrasing and Analyzing Ambiguous Questions in Visual Question Answering. This is work that I did with Jimena Guayar Blasco, Yi Zhao, and Benjamin Van Dermy at Johns Hopkins University. In our paper, we're focused on linguistic ambiguity in visual question answering. Specifically, what we're interested in is cases where annotators provide multiple different answers and where their disagreement reflects that they're actually answering different questions. We introduced a new data set of examples like this, where we have answers grouped by the underlying question that they answer, and then we have questions rewritten to disambiguate between answer groups. We then introduce a disambiguation model, and despite the fact that we don't directly supervise it to do disambiguation, we find that the model is able to recover human annotated answer groups, as well as rewrite questions to be less ambiguous. I'll first take you through how we collected our data. In the dataset we collected, we had annotators perform two tasks for linguistically ambiguous examples. The first was to group answers by their underlying question. In this case, the annotators produced two groups, one specifying a species and the other corresponding roughly to color. We then had them rewrite the original question for each answer group. So for this daisy and hydrangea answer group, the rewritten question might be, what species of flowers are these? And note that this is the same question both for daisy and for hydrangea. But of course, this isn't a valid question for the answer purple. Instead, for purple, the rewritten question might be, what color are these flowers? Because we're interested in examining what makes questions ambiguous, we introduced a 12-way ontology, which has reasons for ambiguity. And wherever possible, we've aligned this ontology with prop bank, and we've manually annotated all of the examples in our data set with these reasons. We then develop a model for rewriting questions. And the model is based on a pre-trained vision language encoder combined with a text pre-trained encoder-decoder architecture. The model takes as input an image and an answer, and it learns to generate questions. Our hope is that over the course of training, the model will learn to generate a question that's less ambiguous than the original. Because the data set that we collect is rather small, we actually don't train on our data at all. Instead, we train on visual question generation across the entirety of the VQA v2 dataset, of course, excluding our annotations. What we find using human evaluation is that our model rewritten questions, as well as the rewritten questions that our annotators produced, are actually significantly less ambiguous than the original questions. When we ask annotators to rate a target answer and a distractor answer, which comes from another answer group, as either being acceptable answers or unacceptable answers to a question, we find a significant drop in the percentage of distractor answers rated as acceptable. This is true both for the human rewritten questions that our annotators produced, as well as the model rewritten questions coming out of our visual question generation model. In addition to rewriting questions with our model, we want to know to what extent its representations can capture answer group information. We cluster answers based on their representations in the model, finding that the visual question generation objective provides sufficient signal to learn similar clusters to the human annotated ones. In this plot, you'll see first that the inter-annotator agreement between humans annotating the same examples on clusters is quite high. We then find that if we cluster model representations using k-means, we end up with a cluster F1 score that's much higher than any of the baseline methods we tested. There are far more results and analyses in the paper, but I'll summarize what I've talked about so far. We introduced a new data set for analyzing ambiguity in visual question answering. This data set includes answers grouped by their underlying question, as well as manually rewritten questions and a prop bank aligned ontology of reasons for ambiguity. We then introduced a visual question generation model that acts as a method for question disambiguation while also representing information about answer groups. As I said, there are a lot more results and analyses in the paper, and I'll talk more about those in the talk. So I encourage you to check out our paper and our talk, and I look forward to seeing all of you at ACL.